In this video, I'm going to show you how to use Stainless Studio to generate high-quality SDKs from an open API spec. When you click into a project, you see several panes. The right-hand side has your open API spec and Stainless config file. The open API spec, written in YAML here, describes the REST API's endpoints using a consistent standardized format. In the sample spec, which represents the API of fictitious virtual pet store, you can see endpoints like pet. The config file specifies how Stainless should map API endpoints to methods in the generated client library. In a Stainless config, methods that operate on a specific kind of object are grouped together as a resource. In this example, there is a pets resource that groups together the API's basic CRUD operations for pets. To learn more about the Stainless config file format and the options it accepts for SDK customization, you can refer to our documentation, which is linked here at the top of the page. When you upload your own open API spec, Stainless Studio uses a large language model to automatically generate a Stainless configuration file that you can use to get started quickly. Of course, an LLM doesn't have a nuanced understanding of your API, so you should edit and review this config file by hand before you release a production-ready 1.0 version of your SDK. The center pane shows a preview of the generated client library. You can see the pets resource and the generated method signatures. Because this is a Node.js SDK, the preview shows the parameters and return values as TypeScript types. When I click on a method in the preview pane, the editor automatically navigates to the corresponding entry in the Stainless config. The left-hand side shows an overview of the resources defined in the Stainless configuration. You can click a resource to navigate to it in the text editor. For larger APIs with many more resources and endpoints than what you see here in this basic example, the overview is really helpful. You can click on the icon to the left of the resource to rename it or to nest it under a different resource in the hierarchy. And you can click the plus icon to easily add a new resource to the config file. At the bottom of the window, there is a panel that displays a tab for each language SDK generated for your project. For now, this project only has a Node tab because I haven't added other languages yet. I'll come back to the Node tab shortly when it's time to test the SDK. The Diagnostics tab shows you errors, warnings, and suggestions from the SDK generator. When you start with an automatically generated Stainless configuration, you may see a lot of diagnostics. In most cases, Stainless can still generate a working SDK for you to try out, so you don't have to worry about resolving all of the detected issues right away. But you will likely want to review them carefully before releasing a 1.0 version into production. For our sample pet store spec, the Diagnostics pane displays one message. To satisfy that recommendation, I just have to add category in the models section of the pets resource. Notice that the diagnostic disappeared when I made the recommended change. Now I want to try my Node SDK and see it in action. Click the Save and Build SDKs button at the top of the window. When the build process finishes, click the GitHub repository link in the Node tab in the bottom pane. When you create a new project, it initially puts the generated code in a private staging repository in the Stainless SDKs organization on GitHub. When you are ready to make a 1.0 release and want to publish your SDK for public consumption, you can configure Stainless Studio to push the code to your own GitHub repo. For now, I just want to test the generated code from the staging repo. Let's take a look at the code that Stainless generated for this SDK. In the source directory, there's a subdirectory called Resources that has a TypeScript file for each resource defined in the Stainless config. When I open the pets.ts file, you can see the methods and corresponding endpoints that are associated with the resource. Notice the readability of the generated code. It looks like code that a developer would write by hand. If I want to customize the logic for one of these methods, I can modify the code right in my text editor and commit it back to the repository. Stainless keeps that custom code intact when it regenerates the SDK. It doesn't overwrite my changes. Stainless also generates a README file in the root of the repository with basic usage documentation. try the generated SDK, I'm going to clone the repository. I cloned the repository and I opened it in Visual Studio Code. To try out the generated SDK from within the staging repo, I first need to install the dependencies and build the source. From the command line in the root of the repository, run npm install. After the dependencies finish installing, run npm run build to transpile the TypeScript source. This step puts the output in the dist subdirectory and the root of the repository. Now it's time to write some code. In the example subdirectory, create a new file called example.mjs. In the file, import the SDK from the dist subdirectory. When you publish your project to npm, users will be able to import it in a more intuitive way. For testing within the staging repo, I'm just importing it directly from the built source. Next, instantiate the imported pet store class. Now call the findByStatus method on the pet store instance. Notice that I get great type hints in the editor while I'm typing. It even offered to complete the string value for the status property using the enums from the OpenAPI specification. Now we're going to log the output to the console. Next, I'm going to run the example from the command line. It returns the output from the pet store application that is running live on the swagger.io website. In just 5 minutes, I took an OpenAPI specification and turned it into a working Node.js SDK. Adding other languages like Python and Go can be accomplished with just a few clicks in Stainless Studio. Try Stainless Studio today by visiting stainlessapi.com.